Hello. In this video, we're going to go over the time value of money concept, specifically the present value of a single amount. In our last video, we went over the future value of a single amount, and we learned that we can calculate the future value based on this formula. We're going to expand on that with the present value. The present value of a single amount has this formula where we say present value equals the future value divided by 1 plus I, where I represents the interest per compounding period, to the nth power, where n represents the number of compounding periods. When we say, what do we mean by when we say present value of a single amount? Well, we learned the future value of a single amount is when we know what our initial principal value is, which in our last example was $1,000. And if we know how many compounding periods we have and at what interest rate, we can calculate the future value. The present value of a single amount is the opposite, in which we are given, not this information, but we are given the future value and want to know how much we need to invest today in order to achieve that future value. So this would be, if I want to have $1,331 in 3 years, assuming a 10% rate of return, how much do I need to invest today? And so you're given this amount and you're giving the number of compounding periods and the interest, and you have to calculate the present value. This is the formula for that. You say, what's my future value, 1,331, divided by this amount. This amount is my factor from my factor tables. But in this situation, we would use the factor table for the present value of a single amount. Let's go through this example. So in this example, I already know what my future value is. I'm trying to figure out the present value. I would take my $1,331 and let me go into my factor table, which I'm still using the same website, but remember, table 1 was the future value of a dollar. That's not what I'm looking for. I'm looking for the present value of a dollar. It means I'm looking for the present value of a single amount. I know what I want my future value to be. I need to figure out what I need to invest today in order to achieve that amount. And so we're going to use table 2, present value of $1. And here it gives me that formula. But in my example, I'm compounding annually for 3 years at a 10% rate. So I look at my n equals 3, that's my compounding period, 3, and I'm going to go across here for 10%, where's the 10% right here? 10% is 0.75131. So when I go back here into my slides and I look at my factor table, you can see I take what I know I want to earn in the future times 0.75131 gives me my $1,000. This is how I can work backwards and figure out what it is I need to invest today in order to achieve a specific number in the future. So let's just go through this some scenarios. So if you're given a choice between $1,000 now and $1,000 3 years from now, you would choose to have the money now so you can earn interest on it. That makes sense. I'd rather take my $1,000 and earn whatever interest rate I can, right? So, but now let's take another scenario. If I'm given $740 now and $1,000 3 years from now, which one would I choose? Would I choose to get $740 now or $1,000 3 years from now? And the answer to that is it depends. It really depends on the interest that you earn on that $740, how much you would earn on it. So again, assuming you earn 10% on that money, if you earn 10%, if you take this $740 today and invest it at 10% for 3 years, you would grow only to $984.94. So how did we get that number? At this calculation, you have to calculate the future value because we know what amount we're getting today, right? You say, okay, so my principal amount today is 740, and what's my factor? I have to figure out the future value of a dollar. My I equals 10%, and N equals 3. So I would go into my future value factor table, which, let's go here. And this is the present value. That's not what I want. I want the future value. N equals 3, I equals 10%, which is 1.331. So back to the slide. I would take $740 times 1.331 would give me $984.94 in 3 years. So if I earn 10% over a 3-year period with investing $740, or do I get $1,000, or would I rather just get $1,000 in the end? I would say, yeah, I'd rather get the $1,000 in the end, because if I invest my $740 for 3 years, I would only get $984, which is less than the $1,000. However, if you were to tell me that I'm going to earn a rate of 11%, well, now I have to figure out how much my $740 would grow into earning 11%. And so then I would go to my factor, my future value factor tables of N equals 3 and my I equals 11%. And I should see a factor of 1.36763, I think it was that number. So let's go, still future value, N equals 3, but now my I equals 11, 1.36763, which is what I'm using right here. So if I earn 11%, then, and I invest $740 today, I would actually end up earning $1,012 in the future. So in that situation, I would choose to invest my $740 today because I would end up with more than $1,000 in 3 years. So this is just some ways to apply future value. Now, what if I don't know one of my components to calculate my factor? So suppose a friend asks to borrow $500 today and promises to repay you $605 in 2 years from now. So then you say, okay, what's the annual interest rate you would be agreeing to? Well, what do I know? I know my present value. That's what I have today, right? Which could be thought of as your principal amount, or your capital I, if you will. And I know my future value is $605, and I know it's for 2 years, so my number of periods is N equals 2, but I do not know what my interest rate is. So how am I going to figure that out? Let's go. So my present value is 500, my future value is 605. Let's go back up into my formula, if you will, right here, where I calculate the present value, and I can see if I just do this. If I'm just going to multiply, let me just make sure this is working right here. If I multiply, why is that not working? If I just multiply 1 over fair value, right, times 1 over fair value, then my formula will end up being present value divided by fair value equals 1 plus I to the nth. This portion, this 1 plus I to the nth, this right here, this amount, represent the factor from the factor tables. That's the entire factor, which we know this piece. We know N because we know N equals 2 in what we're trying to figure out. So let's go back to present value divided by fair value. Let's go back to our example here, where we know the present value and we know the fair value, the future value, and we know the number of periods. So present value divided by future value, right here, we take our 500 divided by $605, and that gives us a factor of 0.82645. Okay, so that's our factor, but we still don't know what our interest rate is. But we do know that part of this factor, this is the present value of $1, right? That's what we calculated. And we know n equals 2, I equals something, but our factor is 0.82645. So we're going to go into our present value of $1 factor tables, looking at n equals 2, and seeing if we can find this 0.82645. So let's go into our table. And now we're not looking at the future value. We calculated that factor using the present value of $1 formula. And we set n equals 2. And let's see if I can figure out the 0.82645. I think it was 0.82645 factor. Yes. So I'm going to go here to n equals 2. And I'm going to scroll until I see 0.82645. If you look at these factors, you could see that they're decreasing as the interest rate increases. And here I see 0.82645, and that gives me interest rate of 10%. So in this way, I have figured out my missing component that for my interest rate is 10%. So if I wanted to go in on this, that didn't work, on this deal with my friend where they asked to borrow $500 today and they're going to repay me $605 in 2 years, I have to be confident that they're going to earn at least 10% on that $500 in order to have money to pay me back the $605 that they've promised me in 2 years from now. So that's determining unknown interest rate. Now, what if we don't know the number of periods, but we have other pieces of information? So you want to invest $10,000 today to accumulate $16,000 for grad school. If you can invest an interest rate of 10% compounded annually, how many years will it take to accumulate the required amount? Well, I know already that my present value divided by my future value equals my factor table, my factor from the table for the present value of $1. That's going to be my formula. So let's see if we do that. So present value today, how much do I need? How long will it take me to earn $16,000 if I compound annually? So I'm going to take my 10,000 divided by 16,000, and it's going to give me my factor table, some factor, so 0.625, and that's using an interest rate of 10%, and we have to figure out what number, how many compound periods is that. So I'm going to go back into my present value of $1 table and look for this factor of 0.625 using the interest rate of 10%. So here I am in my present value of $1 table. I have interest rate of 10, and where do I get 0.625? So if I go here, I don't see 0.625. So even though I don't see the exact 0.625, I'm going to look for the factor that is most closely associated with 0.625. So that's why I'm going to use 0.62092 as my factor, because that's the closest one I have in the 10% column. And that tells me n equals 5. So I would need to invest approximately, if I'm going to have $10,000 today and I want $16,000 in the future, earning approximately 10%, I would have to invest that for 5 years, assuming it's compounded annually.